We are given a few observations. We are asked to explain. Orthonitrophenol is more volatile than the para-isomer. More volatile means it has a lower boiling point. A non-volatile substance has a higher boiling point. A volatile substance has a very low boiling point. When we compare the ortho and para-isomers, orthonitrophenol and para-nitrophenol, we find the boiling point of orthonitrophenol is low. It is steam volatile, but the para-isomer has a higher boiling point. In orthonitrophenol, because the groups are attached to carbon 1 and carbon 2, the proximity makes intramolecular hydrogen bonding possible. Intramolecular hydrogen bonding means the groups within a molecule attract each other. So the hydrogen of the OH group and the oxygen of the NO2 group in the same molecule are attracted. This intramolecular hydrogen bonding does not lead to any association. But in the para-isomer, there is intermolecular hydrogen bonding possible. Because the 1,4 groups are far away, there is no possible intramolecular hydrogen bonding. Therefore, one molecule attracts a neighboring molecule. This resulting association would make the boiling point higher for para-nitrophenol. Malic acid and fumaric acid. We find malic acid is stronger than fumaric acid. That is, Ka1 for malic acid is higher than the Ka1 for fumaric acid. Malic acid is a cis form and the fumaric acid is a trans form of butene dioic acid. The compound is butene dioic acid. When we take the cis isomer and ionize the compound, we have the anion in which the COO minus group and the COOH group lie on the same side of the double bond. Because of the proximity, there can be an attraction between the hydrogen of the OH and O minus of the carboxylate anion. But this intramolecular hydrogen bonding is not possible in the trans form. Thus, the anion is more stabilized in the case of the cis isomer. Since the anion is more stabilized, it has a tendency to ionize more quickly, and therefore the cis form is stronger than the trans form. But you must also remember, because the anion is more stabilized in the cis form, it cannot further ionize easily, and therefore the second stage ionization is more possible for the trans form than for the cis form. The Ka2 is less for the malic acid than for the fumaric acid. The third observation is the carboxylic acids are easily dimerized. We find carboxylic acids have a tendency to dimerize and exist like dimers only. Their apparent molecular weights are approximately double the molecular weight based on the molecular formula. This is because, as shown in the diagram, we find the carbonyl oxygen of one molecule and the hydrogen of the hydroxyl of the second can have a weak attraction. That is intermolecular hydrogen bonding. Now, we find two dashed lines showing intermolecular hydrogen bonding between the carbonyl and the OH of one and the carbonyl second attracting the hydroxyl of the first. This makes dimerization possible. So, intermolecular hydrogen bonding is responsible for dimerization.